Hi everyone, this is Ibrahim Hamid again. This is going to be our first real class on Python programming, and in today's class, I plan to teach us what programming is in a very simple manner. Let's try to answer this question. What is programming? Hmm. Before I tell you what the technical definition of programming is, I'll give you an idea of what we do in programming using a real world example. Let's say I want to learn how to cook jollof rice or fried rice, as the case may be. I've never cooked it before, but I know you are a good cook, and I'm asking you to tell me how to prepare fried rice for sake of illustration. Because of your own experience, you are in the position to teach me how to cook fried rice, even when you are not there. So you start from giving me all of the recipes that will be needed in terms of ingredients. You tell me how to start, what the flow of task will look like, the timeline for the different tasks, the tests that I need to, carry out along the way, and how do I know when my fried rice is ready, to be served. Otherwise, it's going to get burnt. So you give me all of these checks, and by the time you are done, I can say, oh, I now know, at least theoretically, how to prepare jollof rice. What you have done is instructing me on how to prepare jollof rice. Even though I have not prepared any, you have passed the instructions to me. I now know the steps, I know the flow of task, I know the timeline involved, I know what needs to be done at different milestones so that I can have a delicious fried rice at the end of the day. You have succeeded in programming me to be able to prepare jollof rice. In the human form, you have programmed me, you have taught me, you've given me instructions to be able to prepare jollof rice. The same way that happens in the human world, we can have it in the computer world. So when people talk about programming, it simply means a process of issuing instructions to computerized systems or computers to perform some task. And this is usually done by programmers. Programmers are those human beings who have the skills to program computers. And what they do is that they pass instructions to computers to be able to execute some tasks for them. So the question then is, why can't they program human beings to do those tasks? Why do they have to program computers? It's a very simple question to answer. I'll answer it this way. Human beings are brilliant, they are smarter than computers, but they may be sometimes unreliable because of their nature. Human beings can get tired, and that can impact their reliability. If you've worked hard from the beginning of the day to like 3 p.m., wherever your time zone is, your level of productivity cannot be the same as when you were fresh in the morning. In your mind, you would think you are still pretty top notch, but we know you are already going down in terms of your ability to focus and produce the same level of performance as you were able to do in the early part of the day. So, computers are not susceptible to this decline in performance level. They are always consistent, they are always reliable, and moreover, they are extremely quick. So, it's a lot more productive to program computers to do certain repetitive tasks rather than ask human beings to be involved in those things. Humans can't beat computers in those domains, even though we are supposedly smarter than them. So, when I talk about computers being reliable, the reliability is with a caveat, and the caveat is based on how well programmers can program computers to carry out the tasks assigned to them. If the instructions are not well given, your programs, which will be the instructions, now that's what we call programs, the programs will not execute very well. But if the instructions are carefully given, then we will have reliable performance from the computer program being written. So you must have heard people talk about GIGO, garbage in, garbage out. That's exactly the way to summarize my initial point. If you give excellent instructions to your computers, they will execute those instructions perfectly and the performance is going to be top notch. But if your instructions were poorly given, the execution is also going to be poor, and you cannot blame the computer program for not doing what you had in mind, because what you had in mind was not what you passed to it as an instruction set. So we need to be mindful of this. So when we talk about instructions being given, will it be the same way the chef would teach me how to prepare jollof rice? Not exactly. The chef can tell me the instructions or pass the instructions to me in human language because that's the language I am familiar with. It may be English, it may be French, it may be Yoruba, Hausa, or Igbo, whichever language you speak, the chef can pass the instruction to you. But when programmers are programming computers, they need to use programming languages. And there are many programming languages out there. Whichever language you learn, yeah, stick to it, know it very well, and then know the syntaxes, the rules of the language. How do you write it? What are the keywords that are there? So once you understand the language structure very well, you will know how to pass your instructions to the computer. When you're passing the instructions to the computer, there are a number of things that you need to be mindful of. Basically, we do three things in programming. We call them IPO. I for input, P for process, and O for output. Let's pick them one after the other. If you think about input, we're talking about data that your computer program needs to generate output. So if you have written a program to generate people's age based on their birth date, then the input in this context will be the birth date. So if you supply birth date, your program can process it and then calculate the age, which is your output. So input in this context will be the birth date. The process that we are talking about here will be the tasks or series of tasks that the computer needs to carry out on the input given. Sometimes you may be dealing with one input, as is the case when you are calculating the age, and there are many instances when you will deal with multiple inputs. So in real world examples, you are not likely going to be dealing with one input in your program. But in the most simplistic format, you may be having just one input and then you get your desired output from it. So when you talk about processes, we are talking about the tasks that you need to perform on the series of inputs that you have been given in order to generate the output. So for instance, if we are trying to calculate age based on the birth date given to us, we will need to first deduct our birth date from today. We'll pick today's date, we'll remove our birth date from it, and we will get something which will be the difference between the two dates in days. But we usually don't report age based on days. So in order for us to get a more accurate result, you will need to get that intermediate figure, which is going to be in thousands. You need to divide it by 365, which is the average number of days you have in a year. Then you get an approximate value of your age. Most of the time, this figure you get will be in decimal, and we don't report age in decimal again. So you need to truncate the decimal part and return the integer. I'm 21. I cannot be 21.7. I'm either 21 or 22. So if your result shows 21.7, then you truncate the 0.7 part and then you report 21. So this series of tasks that you are carrying out are the processes that are involved in the computer programming. And you must know the sequence. You don't carry out the last sequence or the last task first. The task must be carried out sequentially in order for you to arrive at the desired result. And the desired result in this case is the output, which is the age that we are trying to calculate. Sometimes that may be what you want, and if someone has given a birth date which is inappropriate, you may need to display an output which is going to be an error message telling the user that your age cannot be calculated because you didn't give us a valid birth date. And this sort of scenario could come when people give you a birth date in the future. That is a situation that we need to handle when we are doing processing. So if you give a birth date, we will test it. Is it a valid birth date? And a valid birth date will be either today or something in the past. If the birthday you give us is beyond today, we will reject it. We won't process that because we cannot calculate your age on the basis of that. So in real world programming, you'll be dealing with input, processes, and output. And essentially what you'll be focusing on will be trying to automating, or you need to automate repetitive tasks that people often carry out because human beings can uh, not match the speed of execution of computer in that space. And the objective is for you to have performance improvement of the team that is using your program at the end of the day. So you must know what the logical instruction sets are. You must analyze the processes that you are trying to automate. You must know how to handle input. You must execute your processes accurately. You must display the output to users in the format in which they want them. Your codes don't necessarily have to be long codes. Sometimes one line, two few lines will be good enough. There are instances that you write hundreds or thousands of lines to execute your code, but brevity is a hallmark of programming. We are not just interested in how lengthy your programs are, but how smart the codes work. Then we are also interested in you writing secure code. Your codes must be secure in such a way that people cannot maneuver the program to do what it wasn't intended to do. So people go in the line of application security. They specialize in this area, especially those who will learn how to test your program for you. So at the end of the day, people often ask this question: is programming an art or a science? I tell them it's a combination of both. There is a science part to it, there is the hard part to it. The hard part to it is seen in the area of two, three people being asked to write programs to do the same thing. You are almost likely to see three different programs being written. The three programs will do the same thing but in different ways. That's the beauty of art. The science of it lies in the fact that they are using the same logic to produce the result, and the output is going to be an amazing one. So this is what programming is about. It's the process of instructing computers to do many things for you, but you must know how to handle inputs, you must know how to process those inputs, and you must know how to display the results to your users depending on the context in which you are. This is the story for today. I hope you find it very useful. Thanks a lot. I see you some other time. Bye for now.